Welcome back everyone. In this video we're going to learn about statistics. Here we're going to discuss about its definition, its application, few terms related to statistics, and also how to create a cumulative frequency table. Let's get started. The word statistic is derived from a Latin word status, Italian word state, German word statistic meaning political state. In modern times, we define statistics as science which deals with collection, representation, analysis, and interpretation of data. In the collection phase, we collect all the required data, then we represent this data in some form, like for example the one that we're going to discuss, the cumulative frequency table. Then this table is analyzed and thus interpreted. Let us define the term data. Now data means facts and statistics collected together for analysis or for reference. There are two types of data, primary data and secondary data. Primary data are the ones that are collected by the investigator himself. So if you are doing an experiment and if you are collecting the data yourself, then that will be your primary data. Whereas secondary data, if you are using someone else's data, that is the data collected by someone else, then that is known as secondary data. Let us see some fields where statistics has found its application. Now, statistics has found its application in weather forecasting. That means we can predict tomorrow's weather, whether tomorrow is going to rain or not. That can be predicted using statistics. Finance market, how well a company is doing, how bad a company is doing, that can be determined using statistics. In sports, which batsman plays the best, or during which day or during which weather the ball jumps the most, that can be determined using statistics. It is also used in research. Let us now discuss some terms that is related to statistics. So the first term is frequency. The definition goes, number of times an observation that occurs in a given data. Okay, to understand this definition better, let's take an example. Let's say we have data of number of students sitting in a group. Okay, so we have 7, 1, 2, 7, 8, 9, 6, 12, 2, 7. So frequency of a group consisting of one member is just 1. We can count from here, so 1. A group consisting of 2 members is 1, 2, so 2. A group consisting of 7 members is 1, 2, 3, and hence 3, and so on. Let us discuss the second term, that is class or class interval. It is defined as a group in which raw data is condensed. So these are your raw data. If you have to condense into some group, like for example 0 to 5, 5 to 10, 10 to 15, then these are known as your class. So how do we put on this frequency in the class format? We'll count how many values are there between 0 to 5. So as you can see, this value comes under 0 to 5, this value comes under 0 to 5, this value comes under 0 to 5, and no other values satisfy this range. So we have 3 values that come under 0 to 5. Similarly, for 5 to 10 is 6, 10 to 15 is just 1. Now we have to understand this other two terms related to class, that is lower limit and upper limit. These values are known as lower limit of the class, and these values are known as the upper limit. This counting of frequencies can also be done using the tally mark method. This method is very convenient. In this method, we take one value in the series one after the other, and we draw a stick against the column to which it belongs. Let us understand this with an example. For example, this data. So the first value is 7. Now 7 belongs in this group, that is 5 to 10. So we draw a stick here. 1 belongs here, 2 belongs here, 7 belongs here, 8 belongs here, 9, 6. Now 6 also belongs here, so I could draw the fifth value, but the standard notation is to cut these values. We will understand later why not draw 5 lines instead of cutting this. So let's continue. Our next value is 12. 12 belongs here, 2 belongs here, and 7 belongs here. So we see 0 to 5, 1, 2, 3. So 3. 5 to 10, 5, 6. 10 to 15, 1. Now instead of doing 1, 2, 3, 4, 5, we choose to do 1, 2, 3, 4 and 5, because if we have many values, then it becomes very difficult to count these tally mark. But if we have many values here, it is very convenient. You see, 5, 5, 2. So 5, 5, 10 plus 2, 12. Let us now discuss the third term related to statistics, that is class size. Now class size can be found using this upper limit minus lower limit. This basically gives us how large the class is. For example, for this class, upper limit is 5, lower limit is 0. So class size is 5 minus 0, that is 5. For this class, the upper limit is 10, the lower limit is 5. So class size is 10 minus 5, which is again 5. And for this, upper limit 15, lower limit 10. So 15 minus 10, 5. So we see that class size for this table is same. Let us now discuss the fourth term, that is variate, or commonly known as variable. Here, these are the numbers capable of taking different values. For example, age or income. Now, let's say that you have 10 people whose data is to be collected. Now, it is very common that these 10 people may not have the same age or may not have the same income. Let us now look at the fifth term, that is class mark. Now this class mark is defined as the mid value of the class. Now to find this, we can use this formula, that is upper limit plus lower limit divided by 2. For example, if we have a class 0 to 5, then its class mark will be given by upper limit, that is 5, plus lower limit, that is 0, divided by 2. 5 plus 0 is 5 by 2, which is 2.5. Let us now discuss the sixth term, that is range. Now range is given by the maximum value minus minimum value of the variate. For example, if we have data 1, 2, 5, 6, 12, 52, then here the maximum value is 52, the minimum value is 1, so your range becomes 52 minus 1, that is 51. Let us look at now the seventh term, that is cumulative frequency. Now cumulative frequency is defined as sum of all frequencies up to and including that class. Let's take an example. Let's take classes 0 to 5, 5 to 10, 10 to 15 with frequencies 3, 6, 9. So the cumulative frequency will be sum of all frequencies up to and including that class. So for this class, it will be up to and including this class. So up to this class is the same class, including again the same class. So 3 plus nothing, that is 3. For this, it will be up to this class means 3 plus 6 till this class. So 3 plus 6 is 9. For this class, it will be up to this class, that means from here all the way to this class. So 3 plus 6 plus 1 is 10. Let us now look at the types of frequency distribution. There are two types of frequency distribution, that is discrete and exclusive or inclusive. Let us now discuss the discrete frequency distribution. Now let's say we have data like 1, and this is the frequency, so 1 is repeated once, 2 is repeated twice, 6 is repeated once, 7 is repeated thrice, 8 is repeated once, 9 once, 12 once. So these kind of data are known as discrete. Why discrete? Because these are just one single values. And on the other hand, if we have exclusive and inclusive, then we will have classes. So here we had discrete values, that is 1, 2. Here we have a range from 0 to 5, 5 to 10, 10 to 15. So in other words, if the data is distributed in a class form, then it is exclusive or maybe inclusive. And if these are raw values, then it is known as discrete. Let us understand the difference between exclusive and inclusive. Now exclusive, also known as continuous, inclusive is also known as discontinuous. Let us look at an example. For example, let's take this. So 0 to 5, 5 to 10, 10 to 15. There are three values, 6 and 1. So if we have, let's say, a data 10, then where will it go? Will it go in this class or will it go in this class? Here it is to be understood that these values do not belong to these groups. That is, if you have a value 10, then it will not go to this class, but it will go in this class. Similarly, you have 15, it will not go under any of these. So we'll have to create a fourth class, that is 15 to 20. See, we cannot put 15 here because this value doesn't contribute towards the class. Similarly, if we have 5, then 5 will not go to this class, but it will enter this class. In inclusive form, we see the classes are 0 to 5, 6 to 10, 11 to 15. So already we have noticed that these two numbers are not same. Now if these two numbers are not same, the confusion here do not arises. So if you see, the value 10 is directly placed in this class, value 15 in this class, value 5 in this class. That is, there is no confusion as here. So it is to be noted that in exclusive form, these two values will be same. In inclusive forms, these two values will be different. Let us now dive into some numerical problems. The following data gives the number of children in 15 families of a locality. In the first family there are 2 children, second 2, third 3, 1, 5, 3, 2, 4, 1, 1, 2, 4, 3, 1, 1. So from here we'll have to construct a frequency table. Now how do we do this? So solution, first of all we'll have to arrange the data in ascending or descending form. Now here they have arranged in the ascending form, you can also arrange in the descending form. Then we write the unique values under the table. So the unique values are 1, 2, 3, 4 and 5, and then we draw the tally marks. Now 1, how many ones are there? 1, 2, 3, 4, 5. So 1, 2, 3, 4 and 5. 2, there is only 4 2's, so 1, 2, 3, 4. 3, 1, 2, 3, 4, 1, 2, 5 and just 1. Now we write this in number. So number of families 5, 4, 3, 2, 1. It is as simple as that. Let us look at one very interesting problem. The class marks of distribution is given, that is 37, 42, 47, so on. Find the class size, the limits, the true limits. Now, since the class marks are spaced uniformly, what do we mean by that? If you see from 37 to 42 there's a gap of 5. 37 plus 5 equals 42. Similarly 42 plus 5 47, 47 plus 5 52, and so on. So we can write the class size to be 42 minus 37, which will be equal to 47 minus 42, and which will be equal to all the way up to 92 minus 87, which is 5. If A is the class mark and H be the class size, then upper limit and lower limits are given by these two formulas, that is A minus H by 2 and A plus H by 2. Therefore, lower limits of the first class interval, here we take the first value, that is 37 minus H by 2. H is 5 by 2. Now 5 by 2 is 2.5. 37 minus 2.5 is 34.5. Again, we have upper limit is A plus H by 2. A is 37, H is 5 divided by 2. 5 by 2 is 2.5. 37 plus 2.5 is 39.5. Similarly, we'll have to do it for each and every value. So here we take A to be 42, so this will be 42, 42. Then 52, so it will become 52, 52. So if you do the math, you will get this kind of table. Now this is your class limit. It is to be noted that since the classes are exclusive, what do we mean by exclusive? This value and this value is same. Therefore, true limits is nothing but the class limit itself. Let us look at one more problem. Construct a frequency distribution table with class size 10 of the following data. So this is our data. Now the class size is given, but we don't know with what should we start the class and with what should we end the class. So let's try to find these two first. Here 114 is the minimum observation and 212 is the maximum observation. So range is maximum minus minimum observation. So 212 minus 114 is 98. Now they have given that the class size should be of 10. So this part is not required because the class size is already given, so we don't need to calculate the class size. Now classes of equal size covering the given data are given below. So the minimum value is 114, so we'll begin with 114. So 114 plus 10, that is the class size, is 124. Then 124 plus 10, 134, 134 plus 10, 144, and so on. So this is our classes. Now we can do this with a tally mark. So if you create the tally mark, this is how it looks. You can count the data and see if the tally mark is actually matching. Then you can count the tally mark and write down the frequency. So total we have 30 if you add up all this, and this is how this question is to be done. Let us discuss one more interesting question. So here a cumulative frequency distribution is given, and you'll have to convert this to frequency distribution table. So this is the opposite of what we have been doing till now. We were given a frequency distribution and we had to convert it to cumulative frequency. But now a cumulative frequency distribution is given and we have to convert this to frequency distribution. Let's see how to do this. So this is our table. Below 45 there is 0, below 60 there is 10, below 75, 25, and so on. So if you look at it using this diagram, below 45 means everything that is beyond 45, and there are no values, that is 0. Beyond 60 means everything including beyond 45, there are 10 values. Beyond 75, again everything beyond 60, that is 25. 90, everything before 90, that is 45 values are there. 105 means everything that is before 105, 96 such values are there. Before 120 means everything that is before 120, so 118 are there. Now to convert this to class size or class interval, we will have to convert in this form. So 0 to 45, 45 to 60, 60 to 75, 75 to 90, 90 to 105, 105 to 120. So 0 to 45, 45 to 60, 60 to 75, 75 to 90, 90 to 105, 105 to 120. Now this is very important to understand. 0 to 45. So the table is shown on the left hand side of your screen. 0 to 45 means this value, so it's 0. Now 45 to 60 means this value, so 10. Now here please concentrate. 60 to 75 means this value. So from here to here, if we have 10 values, and from here to here we have 25 values, then in this area will we not have 25 minus 10 values? Let's understand this again. So from 75 to 90. Now before 75 we have 25 values, and before 90 we have 45 values. So in between 75 to 90 there is a rise of 20 values. So basically 75 to 90 will be 20. Please pause the video and try to understand this. If you do not understand, rewind the video and try to understand this, because this is very important. Similarly, we go with all the values, and the final table that is created is shown on the left hand side of. With this we conclude our video. Now practice as many questions as possible from this exercise, and if you have any questions, please drop it in the comment box. Thank you everyone for listening. Take care everyone. I hope to see you in my next video.